If an industrial civilization had risen on this planet 50 million years before us, built cities, burned fuel, filled the sky with carbon, and then vanished, here is what it would look like in the rock today. It would not look like a civilization. There would be no ruins, no bones, no machines. It would look like an event. A sharp warming, a spike of carbon, an anomaly in a core of mud pulled up from the floor of the deep ocean. It would be given a name. It would be given a date. Geologists would study it for 30 years, note a handful of oddities in the data that never quite resolved, and the question of what caused it would remain, officially, open. That is not my speculation. It is the published conclusion of a climate modeler at NASA and an astrophysicist at Rochester. And we have several events in the rock record that match that description exactly. The most famous of them sits 56 million years down, and it released more carbon into the air of this planet than every factory, every engine, and every power station humanity has ever built. Let me be clear from the start. Archaeologists find lost civilizations often, buried cities, forgotten peoples, whole cultures that vanished from memory and were dug back out of the ground. That is not what this is about. Every one of those was human, and every one of them is recent. What nobody has ever found is evidence of an industrial civilization on this planet before our own. No artifact, no machine, no suppressed discovery. What there is a scientific argument, live right now in the last few weeks, about whether our instruments could tell the difference between a dead civilization and bad weather. One camp says the record is a sieve, and something that size could fall straight through it and leave us none the wiser. The other says that is nonsense, and points at what our own species is currently laying down in the mud. And there is one place, according to the scientists who started this, where the evidence would still be sitting untouched after 50 million years, unweathered, unburied, waiting. We have barely looked at it. I will come back to that. But none of it makes sense until you understand the layer. 56 million years ago, the Earth was already a strange place by our standards. There was no ice at either pole. Crocodile relatives swam in the Arctic. Forests reached almost to the top of the world. It was a warm planet, and it had been warm for a long time. Then it got warmer. Global temperatures climbed by something like 5 to 8 degrees. In the Arctic, sea surface temperatures may have reached 23 degrees, water you could comfortably swim in at the top of the world. The deep ocean turned acidic enough that shelled creatures on the seafloor died in enormous numbers. It is one of the sharpest, most abrupt warming events in the entire fossil record. Geologists call it the Palaeocene-Eocene Thermal Maximum. The whole thing lasted around 170,000 years before the planet slowly clawed its way back. The scale of the carbon involved is difficult to hold in your head. Estimates run to several thousand gigatons, some as high as 10,000. That is not a volcano venting. That is not a forest burning. That is an amount of carbon comparable to every fossil fuel reserve we have identified on Earth, released into the atmosphere and the ocean over a period of a few thousand years. And here is the detail that has made this event a magnet for speculation. The carbon carries a biological fingerprint. It is depleted in the heavier isotope of carbon, which is exactly what you see when the source was once living tissue. Plants, plankton, buried organic matter. The same signature, chemically, that our own emissions leave. The same signature as fossil fuels. A vast, sudden release of ancient organic carbon with an industrial fingerprint in rock that is 56 million years old. You may have read that no natural explanation accounts for this layer, that the volume is too large, the release too fast, and that science has simply thrown up its hands. That is not quite right, and it is worth being clear about it. Over the past 2 decades, the picture has become much sharper. 56 million years ago, the North Atlantic was tearing open. Greenland was separating from Europe, and the process was accompanied by one of the largest episodes of volcanism in the last 100 million years, a region geologists call the North Atlantic Igneous Province. But it was not the lava that mattered. It was what the magma pushed into. Enormous sheets of molten rock forced their way between layers of sediment that were rich in buried organic matter, and they cooked it. Hundreds of hydrothermal vent structures have been mapped in the sea floor off Norway, each one a chimney where superheated gas escaped upward, carrying methane and carbon dioxide generated by roasting ancient organic sediment. There is your biological fingerprint, not a civilization, a continent splitting apart and setting fire to its own basement. Researchers still argue about the details, and the argument is worth hearing because it shows you how the field actually works. Some hold that frozen methane locked in the seafloor destabilized as the ocean warmed, and that this amplified everything that followed. Others say the volcanism alone accounts for the carbon, and the frozen methane was never needed at all. One of the scientists who spent years arguing for the methane has said, plainly, that the volcanic evidence is compelling, and that his own mechanism may simply have been an accelerant rather than the cause. That is what a healthy disagreement sounds like, not a cover-up, people changing position when the drilling comes back. So the mystery is solved. The carbon has a source. There is no gap in the record where a civilization might be hiding. And you could be forgiven for thinking that is the end of the film. It is the opposite. Look at what we have just established. A vast release of ancient organic carbon. An isotopic fingerprint identical to burning fossil fuel. A rate fast enough to wreck the oceans. Warming of 5 to 8 degrees. And the cause was a continent tearing open and cooking its own basement, a process with no intention behind it at all. Which means the planet can produce, entirely by accident, a signal that is chemically indistinguishable from an industrial civilization. That is not reassurance. That is the problem. If geology can forge an industrial signature without any industry, then finding one proves nothing. And the one tool we have for reading the deep past cannot tell a species burning coal from a rift valley doing it for free. Which is the question the 2 scientists in 2018 sat down to ask. Not what caused this layer, something far more uncomfortable, whose answer does not depend on it at all. The paper appeared in the International Journal of Astrobiology in April of 2018. Gavin Schmidt, who directs NASA's Goddard Institute for Space Studies, and Adam Frank, an astrophysicist at Rochester. They gave it a mischievous name, the Silurian hypothesis, after a 1970 episode of Doctor Who, in which a reptilian species turns out to have ruled the Earth long before people. The name is a joke. The question is not. We have been an industrial species for roughly 300 years. Complex life has existed on land for around 400 million. Set those two numbers beside each other and an obvious question appears. 300 years out of 400 million. What are the chances we are the first to try this? And here is the part that gives the idea real teeth. There has been enough buried carbon in the ground to fuel an industrial civilization since the Carboniferous period, 350 million years ago. The fuel was there. It has been there, waiting for 1/3 of a billion years. Let me be clear about what Frank and Schmidt were claiming, because a great deal written about this gets it wrong. They were not saying a previous civilization existed. Frank has said it as plainly as it can be said. They have seen no evidence of one. What they were testing was our own instruments. Could we tell? That is the whole paper. And the answer they arrived at is genuinely unsettling. Start with the obvious idea that we would simply find the ruins. We would not. Fossilization is extraordinarily rare. The overwhelming majority of everything that has ever lived left no trace at all. And of the rock that does survive from any given moment in deep time, only a sliver is ever exposed where a human being might walk over it. Then there is the recycling. The ocean floor is dragged down at subduction zones and destroyed, so almost no seafloor older than about 200 million years exists anywhere on Earth. Mountains erode into sand. The planet is not a library, it is a machine for erasing things. So the artifacts go, the cities go, everything you would recognize as evidence goes. Not because it was hidden, but because the planet is not built to keep things. What survives, Frank and Schmidt argued, is chemistry, not objects, signals. A sharp shift in carbon isotopes, unusual metals in a thin band, traces of synthetic compounds, faint chemical stains in the rock, and nothing else. Which brings us back to where this film started. If it happened, it would not look like a civilization. It would look like an event. A sudden warming, a carbon spike, an anomaly in a sediment core. It would be given a name, it would be given a date. Researchers would study it for decades, note oddities in the data that never quite resolved, and the question of what caused it would remain, officially, open. We have those. Not one of them. Several. The Palaeocene-Eocene Thermal Maximum is simply the most dramatic on the list, and we have spent this film watching a natural process manufacture its signature by accident. Frank and Schmidt are not saying those events were anybody's doing. They are saying something worse. They are saying that if one of them had been, the record we currently possess would look exactly the same as it does now. That is not a description of an ancient civilization. That is a description of ordinary geology. Now hold that thought against our own situation, because this is where the film turns from an argument about the past into something considerably closer to home. Everything our species has built, every city, every road, every machine, every book, every war, will compress, given enough time, into a layer of rock a few centimeters thick, perhaps less. That is not pessimism. That is simply what sedimentation does. 50 million years from now, the entire industrial age is a dark stripe in a cliff face, and it would take a very attentive geologist to notice it at all. Everyone you have ever loved is inside that stripe. Which brings us to the disagreement, because a great many scientists think this is far too gloomy, and one of them has said so recently and forcefully. Jan Zalasiewicz is a geologist and paleontologist, an emeritus professor at the University of Leicester, and one of the people who has thought hardest about what our own civilization will leave behind. He co-wrote a book about it, published last year, about what he calls technofossils. He is generous about the Silurian hypothesis. He calls it a wonderful and deeply thought-provoking idea, and then he says it is wrong on the crucial point. Schmidt and Frank, he argues, underestimated two things. They underestimated how completely modern humans have transformed this planet, and they underestimated fossilization itself, how effective it actually is at preserving a record of what has happened here. His argument is concrete. He is happy to accept that we cannot rule out intelligent creatures in the deep past, dinosaurs that sang, as he puts it, or ancient mollusks composing poetry. Soft, small-scale intelligence could vanish completely and we would never know. But industry is different. The moment you build cities, the moment you smelt metals, the moment you manufacture plastics and then throw them away, you are laying down something that does not wash out. Aluminium does not occur in metallic form in nature. Neither does stainless steel. Neither does polythene. These are not subtle chemical hints. They are objects, in quantity, distributed globally, in a single instant of geological time. Zalasiewicz's point is that this is not like a scattering of bones waiting on the right conditions to fossilize. It is a global chemical event with hardware in it. And unlike a carbon spike, hardware is not something you can mistake for weather. And the scale of it is the argument. There is now more plastic on this planet by mass than there are land animals. In deep ocean sediment, in Arctic ice, in the bodies of creatures at the bottom of the deepest trenches we have reached. Every road, every foundation, every landfill is being laid down at once, on every continent, inside a window of geological time so narrow it barely registers as a moment. That is not a faint signal waiting on luck. On his reading, a civilization does not slip quietly through the record. It jams itself into the rock. So you have two serious positions, built from the same rock. One says the record is a sieve, and a civilization would fall straight through it. The other says the record is far better than that, and industry leaves fingerprints you could not miss. Neither camp is fringe, neither is arguing in bad faith, and the disagreement is live right now. There is one more idea in that original paper, and it is the one I find hardest to put down. Frank and Schmidt pointed out that if such a civilization had ever existed, and had reached even modest technological ambition, the best place to look for it is not here at all. Earth destroys evidence. It has weather, rivers, oceans that swallow, and plates that recycle. The moon has none of those things. No atmosphere to scour a surface, no water to dissolve anything, no tectonics to drag it under. A footprint left on the moon lasts for millions of years. So if anything ever left this planet, a probe, a lander, a piece of debris, anything at all, the evidence would still be sitting up there, unweathered, waiting. And we have looked at a vanishingly small fraction of those surfaces at any real resolution. Which quietly turns this from a geology question into an astronomy one. Because think again about that number. 350 million years of buried carbon, available to anything with the wit to dig it up and set fire to it. 400 million years of complex life on land, some of it social, some of it tool-using, some of it with brains we would recognise as formidable. And in all of that time, on all of that fuel, exactly one lineage has ever lit the match. That is either an extraordinary accident of timing, or it is telling us something we would rather not hear about how rarely this particular door opens. It is the same question we ask when we point telescopes at other stars and find a silence we cannot explain. Why does nobody seem to be out there? Only this time we are not asking it about a distant sun. We are asking it about our own back garden, about the rock beneath our feet, and we still cannot answer it. So where does that leave us? The layer is real, the carbon is real. The best explanation for it is a continent tearing open and cooking its own sediment. And that explanation is well evidenced. There is no serious scientific case that the Palaeocene-Eocene Thermal Maximum was anybody's doing. But the question underneath it has not been answered, and it is a genuine question. If an industrial species had risen and fallen in the deep past, would the rock still be holding the receipt? One group of scientists says almost certainly not. Another says almost certainly yes, and points at the aluminium. The honest position today is that we do not know. Not because anyone is being lazy, but because the question is difficult and the evidence is thin, and the people arguing about it are good at their jobs. And there is something quietly magnificent in that. A species on a small rocky world, drilling holes in the floor of its own ocean, reading the chemistry of mud that settled before there were primates, and using it to work out whether it is the first of its kind. We built the tools to ask that question out of curiosity, and we are still arguing about the answer. Meanwhile, the layer we are writing carries on, thickening, quietly, underneath all of it. Whoever reads it will see a sharp spike in carbon, an unusual concentration of metals, and traces of things that do not occur in nature. Whether they will understand what they are looking at depends entirely on whether they have already had this argument. And if they have, if someone out there is holding a core in their hands and wondering the same thing about us, then the honest hope is not that they find our cities. The cities will be long gone. The hope is that they find the question.